Today we are learning about the chain rule. The chain rule helps us take the derivative of composite functions. So for example, 2x minus 1 to the 7th. This is a composite function because we can look at this as if g of x is 2x minus 1 and f of x is x to the 7th, then y would be f of g of x. Now for this particular function, we can take the derivative using the power rule, but we'd have to do a lot of distributing to get 2x minus 1 to the 7th power to get all of our monomials to then use the power rule. So I'm going to demonstrate now how to use the chain rule, but using two different types of notation. So let's start off with our y can be expressed as this composition of functions. And we're going to call g of x u, which means that y can be written instead of f of g of x as f of u. Then the derivative of y with respect to x is going to be the derivative of y with respect to u times the derivative of u with respect to x. All right, so our example was 2x minus 1 to the 7th power. U is our inside function, that's g of x, or 2x minus 1. So y can be expressed as a function of u, or just u to the 7th. So now our derivative is the derivative of y with respect to u. So the derivative of y with respect to u would be 7u to the 6th power times the derivative of u with respect to x. The derivative of u with respect to x would just be 2. So we can write this as 14u to the 6th, but u is equal to 2x minus 1. So 14 times 2x minus 1 to the 6th power. And there is our derivative. Okay, we're going to do one more example using that notation. And we'll take the derivative of the square root of x squared plus 5x. And before we do that, I'm going to write that using an exponent. So we do have a composition of functions. Our inside function, which we'll call u, is x squared plus 5x. And then y is really u to the 1/2. So our derivative is the derivative of y with respect to u times the derivative of u with respect to x. So dy du, the derivative of y with respect to u, is 1/2 u to the negative 1/2 times the derivative of u with respect to x, and this derivative will be 2x plus 5. Now we'll do a little substitution. So we've got 2x plus 5 over 2, and u to the negative 1/2 will be x squared plus 5x to the positive 1/2. And there we go, there is our derivative. All right, let's look at our second variation on notation. The derivative of a composition of functions is equal to, now remember before we had the derivative of y, which is the derivative of the composite function, times the derivative of u, which was the inside function, or g of x. So same thing, just using some different notation. So if we revisit this 2x minus 1 to the 7th power, the derivative will be the derivative of the outside function with the inside still there. So the derivative of 2x minus 1 to the 7th, we'll bring the 7 in front, 2x minus 1, subtract 1, we get to the 6th power. And then we have to multiply that by the derivative of the inside function. The inside function is 2x minus 1. So that derivative is just 2. So we get 14, 2x minus 1 to the 6th power. And then our second example was the square root of x squared plus 5x, which again we'll use exponents for. So the derivative is going to be the derivative of the outside function with g of x still inside, so we'll bring the 1/2 in front, x squared plus 5x to the negative 1/2, times the derivative of g of x, which is 2x plus 5. So that's 2x plus 5 over 2 radical x squared plus 5x.